My name's Eric Wittner. I'm the 3D technology evangelist for Esri. I'm here with Rob Matthews, who's our Geodesign Practices Manager and Professional Services, Nathan, who's our 3D visualization lead, and Brooke Patrick, who's a solutions engineer on the CityEngine team. And what we wanted to do today is actually take you through the first part of that wheel, which is the planning and design portions. Starting at a smaller scale, at the city scale, doing a transportation intervention to create new development opportunities in a city, doing assessments of those and driving that through analytics using GeoPlanner, which is a web-based tool. Carrying that along and moving into ArcGIS Pro, which is our new desktop technology, to enhance that design and better understand it and create better representations of it. As we get an understanding, to carry it on, to actually move to more specific design, to get all the way down onto the streetscape, to actually do individual street design. So I'm going to turn it over to these guys to actually walk us through that process, through all these technologies and how they link together. Rob?
Great, thanks, Eric. Hi again, my name's Rob Matthews. I'm the Geodesign Practice Manager, and I'm going to be working with GeoPlanner. So GeoPlanner is a web-based application that sits on top of ArcGIS Online and provides a really great set of tools for rapid iteration and exploration of urban design and urban planning questions. So I'm going to walk through the first step of this, which is looking at the regional scale and then getting down into some specifics at a site scale before I hand it off to do some additional work with the rest of the team. So let me just give you a quick background on the presentation I'm doing. So we're going to be looking at adding bus rapid transit to the downtown corridor, or to the downtown area of San Diego. And these BRT lines are a great way to add capacity really quickly. And we want to make sure that we get the alignment of the BRT correct and that the stations are in the right place and so forth. So I'm going to first show you an example of our first alignment concept that we've created. But before I do that, I just want to ground that in the existing context. So first, I'm going to just turn on the existing land use types. So this is from the comprehensive or general plan. You can see that there's some, if I turn on the legend here for you. Oops. Here we go. You can see that there's some core areas, some civic areas, and a ballpark mixed use area and so forth. So the city's already got a sense of where they want different land uses and densities distributed. So now we need to respond to that. And I'm going to look at some additional context here. I'll turn the land use off and turn on the other things that we can use to make some of these decisions, like the existence of existing bus transit, the existing light rail downtown, which is really important, as well as different parks and the entrances to those parks. And all of those things are, as well as the presence of existing jobs and households, are what we're going to take into consideration when planning this line. So first, I'm going to show you the alignment A. So alignment A runs down Balboa Park here, downtown. Looks like a perfectly good alignment. And it's obviously got some connections to the light rail and so forth. So what we're going to do now is use a suitability surface to dig a little deeper and use data to enrich this process. So I'm going to set up a suitability model. And that suitability model looks like this. And this uses a weighted raster overlay, which is a very sophisticated technique that we've made a lot easier to use through this. So I'm going to, first of all, take a look at which layers I'm using to inform the suitability. So I'm looking at proximity to existing bus, light rail, and urban parks, as well as existing population density. But because we're also looking to stimulate real estate development, we also want to understand what the potential for future development is. So, for example, I can say, if we're going to use high FAR, or floor area ratio, which is a metric of density. So if it's an FAR of 20 or 14, we're going to give those very high numbers. So the higher the number, the more suitable. And the color green, in this case, represents the most suitable. And those numbers get smaller as you get towards lower and lower development potential. And the same is true for proximity to light rail, for example. If it's very close to light rail, it gets a good suitability. And if it's far from light rail, it gets poor suitability. I can also weight each one of these layers individually. So in this case, you can see that I'm giving light rail proximity a higher value than bus proximity because it's a little bit better ride, and it's just people generally prefer to take light rail over bus if they have an option. And so I can run this model, and for the purposes of the demo, I'm not going to be running these things. They only take a few seconds, but I just want to make sure we can cover all the ground. So I'll just show you the results of the model, and that looks like this. So you can see that in our alignment A, The areas in green are the most suitable, and the areas in yellow are somewhat suitable, but not perfect. So I missed the mark a little bit with this alignment, and you can see that very clearly using this underlay. So next what I'm going to do is show you another alignment that I drew really quickly. It's alignment B, and you can see that we've done a little bit better job here. We're always covering these green areas, and so this represents probably a better alignment in terms of picking up future development potential. So that's great, but what we want to do is look at some specifics like what's happening down here at the ballpark. Before I do that, though, I actually want to show a couple of other really exciting things that you can do through the online environment. And I just want to mention that all of this analysis is happening live. It's all in the cloud. And so there's no software, again, installed on my local computer to do this. So the next thing I want to do is look at walk sheds and just understand if I've really picked up the existing jobs and housing the proper way. So to do that, I'm going to just go to an assessment here. And I'm going to use this tool here it's called Create Travel Time Areas. And I'm just going to use my platforms here. And I'm going to specify a walking distance. So you could do drive time or walking distance. This is being calculated against the underlying network. So this is actually a true walk distance, not just a sort of as the crow flies distance, which is really important when you're talking about the subtleties of development downtown. And so I can just put in here, I would type in an 1/8 mile, a 1/4 mile, and a 1/2 mile distance. And then I just run this. And again, I'm not going to run it live. It only takes about 2 or 3 seconds, but I just want to make sure we can have time here. So after I've run that walk time analysis, it looks something like this. And I'll go ahead and turn off the weighted raster underneath it. So the areas that are in the light purple here are the most suitable. Or sorry, the 1/8 mile, and then the next ring is the 1/4 mile walk distance. So I can clearly see what's sitting underneath that. And the next thing I want to do is to show you how you can enrich this data using the Esri curated demographics. So again, I can just come back up here to Analyze and Enrich Layer. In this case, I'm just going to pick my walk shed layer, and I'm going to pick some variables. And this gives you access to all of the Esri curated demographic information. So this is really powerful. So I'm going to just pick households and total 2014 households to represent the existing condition. And I will also pick information for jobs. So I'm going to look at the total Dun & Bradstreet jobs and apply that. And then again, I just run this. Just use your imagination for a second on that one. So I run the calculation. This one probably takes about 5 or so seconds. And with that information now, I can look at how well I'm doing with this plan by using a dashboard. So you can see here that what you see on screen, all these station platforms have 37,000 jobs within a 1/4 mile walking distance. And I was able to get this information in literally a couple of minutes. So you can see that this is really effective at getting feedback. And I can also look at the 1/2 mile, 17,000 households within a 1/2 mile of these stations, and 66,000 jobs. Okay, so that's really useful information. But I can take this a lot further, and I'm going to now drill into the specific station area down here. So when you can see from the suitability, we picked an area for one station that was in an area that was medium suitability. And the reason why is that let's just say that the Planning Commission identified the need to have a BRT platform that supported the Petco Park area, which makes a lot of sense, right? So in this case, I want to demonstrate how this can be used as an iterative tool. So we can just accept that the land use conditions are what they are, or we can go in and redesign those. And maybe we suggest an alternative density that helps support the real estate development around that station. So I'm going to go back to another scenario here. It's really easy to create these scenarios and manage the information. And I'm going to look at the, let me zoom out a little bit here. Actually, before I show that, let me show one other thing here. So I'm going to turn the base map to a different color to make the information a little bit easier to see. So this is the actual floor area ratio development regulations for downtown. And you can see that there's a couple of key core areas as well as the ballpark area down here, and then the rest is sort of residential and mixed use infill around it. But we're not really interested in the overall FAR plan, right? What we want to do is focus on the areas that have actual development potential. So that's what's shown in these areas. Unfortunately, the city has already identified these. So now what I want to do is come back down into this area by the ballpark, and I'm going to change my base map back to imagery so you can clearly see what it is we're working with. And I'm going to make some adjustments to this as a new scenario. So I would just create a new scenario, which I've already done ahead of time again here. And my scenario in this case, let me go back to my legend and explain what these land use colors mean. So here you can see the ramp of FAR from lowest to highest. So the dark reds are sort of medium-high FAR or density, and then the purples are the highest density that the city currently allows. So the other plan had a lot of lower stuff in here, and this one has, in this scenario, it's got a higher density. So it's really easy to change these things. Let's say I want to take this particular area that's a parking lot that's already defined as an area. I can change the land use category in here really quickly to 20 FAR. And you can see that updated automatically. And then I can also draw some new areas. So the drawing and sketching tools in here are really easy to use. I just make sure I'm on Create. Then I'm going to pick which type of drawing I'm going to do, whether it's points or lines or polygons. And then I'm going to just scroll to the appropriate area for the legend that I want to draw with. And in this case, I'm going to draw in an area of 14 FAR that supports some additional development down here. So again, this is not a real plan. This is just a concept. So let's just say that we're lidding over the light rail support yard down here, and then in order to develop on top of it. Okay, so I've created that shape, and now that's adding information automatically. If I look at my dashboard, you can see that I've got a certain amount of development here. And what I want to do is now compare my first alternative and my second alternative side by side so you can clearly see whether or not we're getting close to these targets that we've set for ourselves. So to do that, I'll just go to the compare function and turn a couple of things off here to see a little better. And I'm going to zoom out back to the entire city, center city boundary. And just make sure that we're looking at the right things here. Okay, so I've got alternative 1 on one side and alternative 2 on the other side. Now, notice that the light rail, or sorry, the BRT alignments are the same because we've already decided that that's our preferred alternative. Now the alternative we're looking at is the different densities of these FAR areas down by the ballpark. So you can see that this is darker down here, and this is the original one. It's a little bit lighter, a little bit lower FAR. And I can open up my dashboard here. I'll just adjust these so that we can see them side by side. And you can see that, let's look at households first, that the chart shows me that I have 36,000 households on this side and 31,000 on this side. And this little yellow marker here is a target. So let's just say that the target for the housing is 40,000. So pretty far away from it on this one, getting a little closer on this one. But if we look at jobs, we can see that the alternative 1, which is actually on the right, has 87,000 jobs within the area, and the one on the left is 102,000 jobs. So we've actually exceeded our target on that side. It's really easy to set these up. You just give it a title, you give ranges to the individual chart elements, you can set a target if you want, and then you can just use a simple formula. In this case, it's looking at the area of the polygons that are within the planning area, and then multiplying it by the FAR, and then a constant that represents development potential. So the last thing I want to do then is just come back to an overall image of what the FAR looks like. So I'll open up my table of contents again and show the FAR designation. And so let's say that we are now going to hand this off, and that it might be a really good idea to add density down by the stadium, but maybe some other people are going to want to weigh in on that, to think about the aesthetics of higher density, to think about the solar access issues, to think about the kinds of utility infrastructure issues we may come across. And so what I can do is export the information from GeoPlanner to a shapefile or a geodatabase, or even to a CSV, so you can use it with Excel modeling. And then we can use that information to continue the geodesign process, looking at those specifics at a finer grain and in 3D. And that's, with that, I'm going to hand it off to Nathan.
Yeah, I have a quick question for you, Rob. So in looking at this tool, right, we've seen editing on the browser, we've seen dynamic dashboards and creating of charts in the browser, scenario management, right, all software independent, all in the cloud. Can you talk just briefly about using this as a collaboration tool? So you have multiple participants who want to simultaneously design something or make multiple alternatives in the way it organizes projects.
Yeah, that's a great question. So the way that this is designed is inherently meant to be collaborative. So first off, you have access through the internet, so it's really easy to get to this information. It's designed so that people can share scenario authoring, you can move information back and forth quickly, and if you're working on a design team, it supports both collaborative work with one person driving and other people talking about it, but it also gives you the opportunity to have lots of people, different people creating different scenarios, and then we can look at those and compare so that you really get to pick up the expertise of lots of different people who have different values that they're bringing into the planning process.
And then if you actually had, for instance, ArcGIS Server and the image server extension, you could push your own analytic maps up in there and do overlays with your own data.
That's right, yeah. So it's designed to give you a lot of information out of the box, and then of course you can load public data and so forth, but you can also use your own proprietary data if you have it, and like Eric said, if you want to do customized weighted raster overlay analyses, you can host those on an ArcGIS server, and then you can do whatever you want with that.
Yeah, and then share it back in the enterprise. I'll turn it over to Nathan.
Okay, hi. Hi, my name's Nathan Shephard. Am I on? I don't think I'm on. Am I on? Oh, good. I can't hear myself. That's weird. All right. So here we are with ArcGIS Pro, and we're moving on to the next level of investigating this design. And a desktop app like Pro is really good to integrate in many other data sources, start running different kinds of analytics that rely on different data types, maybe some more advanced analytics, and also to visualize those designs. And the cool thing about Pro is it lets you do it in 2D and 3D. So first thing I'm going to do is add in that first design. It was given to me as a layer package. So when I use a layer package, you just bring it in, and it's using all the same symbology that we saw before. You can see all the content where it's drawing here, but this is just 2D. If I want to bring it into 3D, all I have to do is just copy this layer, switch to 3D, and paste it in. And in it comes. And again, same data, same symbology. So this is kind of one of the advantages of having 2D and 3D at your fingertips all in the same app. But again, it's in 3D, but it's still using 2D symbology. So let's bring it up and add some 3D symbology to it. And right now it's using a sort of a traditional, if you like, unique value renderer. And all the different types of FAR are being, the floor area ratio is being used. I'm going to mix it up and we'll just say, well, let's go for a single symbol. But not that brown. Let's do something a bit nicer than the brown. And I'll wait for my gallery of symbols to load. So some of the symbols that I have here are procedural symbols. And procedural symbols are authored in CityEngine, and then you can just register them with Pro and use them just like any other symbol. So I'm just going to pick one here. Let's use this FAR 3D symbol. And with a single click, I've turned that layer into a 3D representation. And in this view, you can see the real close relationship between the height of a buildable volume with the FAR. You know, if it's a lot of density, a lot of people need to live there, you have to build up. So it kind of really brings that to life. And it's a 2D, 3D app, so I can have them side by side, cruise around and look at it in 3D, or we can always come over here in 2D and look at it here as well. And if we want, we can just link them together. And now as we pan around in the 2D view, we'll see the 3D representation of it at the same time. So this just looks like extruded blocks. I just want to talk a little bit more about this symbol that we're using, this procedural symbol. So we've got a lot, and it looks like it's just extruded up. Here in my linked 2D view, I can see it's this guy here. So let's select it in the 2D view, and we'll look at its properties. So it's got some attributes here. One of them that's interesting is this front setback. It's currently set to 0. Let's make it 15 meters. That didn't do anything. We're just changing an attribute in a table, right? But if we come back and look at our view, it's meant to have changed that guy, but it didn't. That's very strange. We select this guy. We'll have his attributes. And it doesn't want to redraw for me, which is the first time it's ever failed I think, ever. So I blame Eric. Normally it steps back nicely and looks great. So you're going to have to use your imagination there. It'll be interesting to see if my other symbols work. Okay, so here we are back in 3D. Now we're just looking at this all together. Let's add a bit more context to this. We're in 3D. We need to know what's going on with the buildings that are already here. So we'll go and look at the setback. Oop. We'll actually go and look at the context. And we'll turn on our buildings. You can see that some buildings are being swallowed up by these volumes. They're kind of underutilized buildings that could maybe be knocked down. But now we're starting to get a feel for what the city looks like right now. And these are actually pretty good buildings. The geometry is really good. They're from pictometry, but we don't have any textures. We don't know what use these buildings are currently subscribed to, and we don't know the number of floors. So we can just come in and change the symbol for them. So without doing any data changes or anything, we'll bring in properties for it, and we're going to split it by floor. So again, I just pick a symbol, come back, and it redraws. So now I can see they're colored by the land use, and I can see the number of floors for each of these buildings. So it's the same data, but just a cool symbol on it makes it look good.
Yeah, I just want to highlight what's happening here. This is actually not a procedurally generated building. This is something new. This is applying procedural rules to existing buildings. It takes that building, it splits it, it can display usage inside, it can generate performance metrics based on its total floor area inside. So now you have this ability to do common things between existing 3D models that you're bringing into the GIS and procedurally generated models that you're building from footprints or parcels to give them kind of a common foundation for comparison. Sorry.
No worries. So, like all symbols, they have properties, and we can change some of these properties. So this is kind of like being rendered by topology, but we can just say, you know what, let's not use that coloring. Let's use a different trick to display it. Instead of doing usage, we're going to do procedural textures. So again, these are 3D models without textures, and we just apply a procedural symbol, and we can add textures to them procedurally. And this will create a realistic view. So now, these aren't the real textures, obviously. They're procedurally generated, but we get a feel for what the city looks like. Sort of adds that realism. So this can really help explain the context around a design. So far, we've just been doing some cool stuff with symbology. Let's actually do some design work. So we'll go back to side by side. I will go to 2D. We'll turn off this and come in. This area there. So this is the area that we're building. I'll just zoom in so we can see it. All right. So we want to place a new design here. We want to design a building. We're at a tighter scale. And all I want to do is create features. I'm going to create a 10-story apartment. And I'm going to click to start adding it. And I can do some precise placement of my next vertice. So in this case, we'll go 200 feet to the right and 0 up, so due east. And that's my first part here. And then just start constructing it. So 90-degree angle, say 250 feet. And we'll do a 90-degree angle. Oops, it's a 30-degree angle. 90-degree angle. Say 150 feet. Don't have to talk out loud. And then I'll come over here, right-click, square and finish. So there's a precisely placed building. Obviously not a very interesting one, but it shows you how it all fits together. And I can rely on this. That's why I edited it in 2D. Nice and simple to do this kind of top-down view. Now what's going on here in the 3D view, right now we don't see anything, but if I turn on that same layer in 3D, you can see that it's got a representation like this. And again, this is just a polygon, but we're using one of these procedural symbols to render it. So if we look at the attributes for this selected polygon, actually, over here, selected polygon, right now it's got a height of 35 meters. So if we make that 42 meters, we'll effectively add 2 more floors, and it added it. If you don't believe me, we can undo that edit, and we can redo that edit. So that's how easy it is to make these changes. And if we drag this guy back on the top and look at his symbol, again, just like before, we can say, you know what, we don't want to see it like usage, we want to see it textured. Apply that change, and now we've got this representation, and it's using the same rules and the same assets as the other rules, so it looks the same. It fits in with the other buildings around. So you can create, just on the fly, sort of mess around with designs and get that different looks, whether you want it just as a block view or if you want it with a sort of a realistic feel. So all of this has just been done on the fly. This is not really a good design. I kind of can't help but do something like this to finish off this demo. And that's like you chop a corner off. Everyone loves chopping corners off buildings. And you come back, and there it is. So very cool, very addictive, and you'll waste lots of time. But you'll smile. So let's move on to a real design. That's something that's actually going to add some value. So here in 3D, we'll go down to our area of interest. So this is down near the ballpark. And we've done some proper design. Well, let me rephrase that. Rob's done some proper design to come up with some proposed buildings that fit the FAR and fit in with the potential design here. So that's what they look like. You see we've got some mixed use and some other cool stuff. But before we look at what we're going to make the changes to, we should always understand what we're starting from. So some analytics that Eric ran for solar radiation will kind of show what this area is like in regards to solar radiation. So this is not just some sort of solar radiation raster. It's actually a kilowatt-hour radiation surface from Eric. And it's being rendered here with this really cool color ramp, custom color ramp, really easy to build, where we use transparency on the low end and red on the high end. So it kind of has a sunburned effect. So where are you getting sunburned? Where do you put sunscreen on? But for this whole area. And from this distance and looking at this content, you might think, wow, that's one big heat island. It's just soaking up all of this radiation and being really hot. Well, some stuff that helps reduce that is wind. So we also ran some wind analysis. So here we have a 6 mile an hour wind coming from the southwest. Come down, and you can sort of see how this has been modeled and how it bends and twists around between all of the existing buildings.
Yeah, so just briefly, the transparent ones are where you actually have areas of slow wind, right?
Which preempted my next statement.
Sorry.
So the transparent areas is where you have slow wind. Thanks, Eric. So we did practice this too. It's kind of interesting. So this area here, it's in the lee of the stadium. So it's protected. It doesn't have as much wind coming through, and it does have a lot of solar radiation. So this is a potential hotspot where we have this little heat island. Something that can help alleviate that. These cool things called trees. And you can see that these are well placed. These are actually the real trees that are placed there I got this from Sandag. And in the afternoon, you can see how well they protect this area. So that's good, right? There's no problem here. So we'll turn off this, and we'll zoom back out. And if we look at the proposed buildings again, before we do the solar and the wind again with the new design, let's just get an idea of what else is around here. So there's actually existing water and sewer pipes in this area. And nothing is developed in a vacuum. There's things here already. You might impact things you don't even know about. And just some sort of simple analysis you can do as well. If we build these buildings, are we going to have to dig up pipe or accidentally hit some stuff? So we'll do a select by location. We're looking for any of these buildings that are going to intersect the water mains, and we'll include a 2-foot search distance because you can't trust guys in bobcats. And just like that, we've got our selection. We can click down here and it'll zoom us to our selected features. Okay, so great. So these are the ones we know about. Maybe we need to change the design. Maybe we just need to allow for this properly during construction phase. That's the kind of spatial analysis that you need to take account of in a GIS and just in general. Okay, so let's turn solar radiation on for after. And again, we've got that same heat island. We're not impacting that at all. It's the same results. And if we look from the side, see some areas here. These are well protected. They're not going to get too much solar radiation. But in these canyons here that go north-south, it's still getting quite a lot of sun. So there's a lot of heat hitting these guys. So what is our wind doing for us? So we rerun the analysis, and you can see here that the wind comes around and turns around the corner. Just worth noting, these arrow symbols are just regular symbols. They're not procedural symbols, so you can still do a lot of cool stuff just with attribute-driven rotated arrow symbols. You get a really cool idea how wind speed compresses and speeds up. It's quite interesting. But more importantly, and actually usefully, we find some more of these areas where there's lots of solar radiation and low wind that we might be interested in protecting somehow, maybe by planting some trees. So I could plant some trees now, include that in the design, or we could solve or attack the problem parametrically as part of like the street design. So I'm going to hand you over to Brooks, who's going to show you how CityEngine can be used to geodesign a cityscape.
So just want to make sure, anybody who doesn't know what ArcGIS Pro is, raise your hand. Okay, people in the AV box don't count. Good.
Thanks a lot, Nathan. So I'm going to speak to you a little bit about CityEngine. What we have here is actually the same scene, so we're still working in this area right next to the Petco Stadium. CityEngine is an advanced modeling tool, and it's meant to support this rapid design and really the implementation of new planning and urban design strategies and capabilities, both at the city level, but also at the neighborhood level, and even down at the street level. So while at the same time improving the communication, enabling really accessible real-time 3D solutions, and you'll know what I mean by that in a moment. So this real-time 3D is actually made possible with CityEngine's procedural 3D modeling. If efficiency is actually important to your 3D pipeline, then you're probably going to like this. So we're starting here with GIS data that you saw in Nathan's demonstration and also Rob's demonstration. So we're really bringing the data all the way through to CityEngine and going into this next level of detail. CityEngine can bring in both GIS and CAD 2D and 3D, native OpenStreetMap. It's actually one of the better importers I've ever seen. And actually many industry standard 3D formats, both 3D object format, but also imagery itself. So allow me to give you a quick demonstration of one of our new examples, the complete street example. So I'm going to go ahead and turn on some blank streets here. So along with all the other data, we're actually able to bring in street center lines. In GIS, we refer to them as network data sets, or in CAD, they're polylines. And CityEngine automatically models out a street and two sidewalks and intersection shapes that we can use to actually model these streets fully in 3D. So I'm going to go ahead and take my complete street rule example and drop it on the street. And you'll notice right away it generates a default street layout that really gets you a starting place to work with that street. This is a little different than your other parametric tools like Grasshopper or even some fancy plugins for Rhino. We're actually not only able to use those shapes to inform how it gets modeled, but use attributes to actually determine street width, the parking styles, the different objects or medians that exist on all networks, and have that rule actually model it on the fly. So the more data you have bringing in to this environment, the easier and more automated the modeling process is. And you can see I've gone ahead and generated all the streets for San Diego. Don't try this in SketchUp. If you're using SketchUp or Maya, it's pretty much equal output to equal input, so labor intensive, and that's been the traditional feeling or regards towards 3D for a long time. And of course, in the end, you're still stuck with a static model as well. So I'm going to zoom over here to this street here. San Diego is interested in creating a variety of multimodal upgrades. Just east of the gas lamp, that's where we are situated here. Seen in the previous demonstrations, Rob had mentioned BRT. We're actually going to get to that as well. To work with this data, we're going to need a flexible design environment. So these rules actually allow you to model with parameters. This particular street example rule has tons of capability, literally at the flip of a switch. So you can see already how many different parameters we actually have to work with here. So I'm going to go ahead and specify 2.5 meter bike lane for both sides of this street here. We can go ahead and specify a 1.2 meter buffer for each of those bike lanes. And so we can really start applying these components to the right-of-way itself, work with the area we have, start assigning these different street treatments. And even whether or not the buffer is protecting the bikes or the cars that are parked, right? In San Diego, the bike lanes aren't green, they're actually red. They're not red, they're actually green, so you can flip those. And in addition to modeling bike lanes, there's actually different buffer configurations as well. So we have painted stripes here, but we can look at cycle track with planners. Take a second to regenerate. I'm actually going to zoom in here so you can see it a little bit better. So planners, we can actually look at tubular markers as an option. We can even look at a curb with trees, right? So this is really robust. If you're familiar with CityEngine, it's not only about creating the 3D model and taking a look at it, experiencing it. We're actually able to generate metrics dynamically while we start to make these changes. So for this particular rule, I can zoom down here to the reporting window. And this is outputting tabular reports. And so what we've done is actually reference a popular report called the Mineta report on low stress bicycling. And we're actually able to report out on the fly an LTS standard score. So we're actually looking at the width of the bike lane, the speed of the traffic, the type of buffer, et cetera, all in calculating this score. And so that really means we're able to quantify how I would feel biking down this lane versus Nathan and his kids, right? So it's really being able to quantify that qualitative design. So these metrics can actually be able to describe the environment that you're modeling, but also prescribe. So we've gone ahead and imported all of those proposals that came from you guys. We actually detailed them a little bit further and actually worked the land use in conjunction to the streetscape itself. So earlier in the demonstration, Rob was working with a couple of BRT options. We actually went with the option that goes right next to the Petco, right next to the Padres, and uses two one-way streets that you see up here to the north of the stadium. So we're actually able to very quickly model out what that might look like. And CityEngine, as you saw in the previous demonstration, also supports different ways of viewing data on this 3D surface. So not only looking at different land use on buildings per floor, but if we take this street here, we've actually gone ahead and programmed in a usage visual for those streets as well. So this actual visualization might look a little familiar to you if you're familiar with street transportation planning. It came from the NACTO book for Urban Street Design Guide, and it represents a lot of their diagrams. So you can basically create a lot of their diagrams here in 3D on the fly. I'm going to go ahead and turn that back to the rendered view. And it's not only about usage, you can actually visualize stress on all segments of the city as well. So once you have this alternative or option, you can actually create the existing, create the redesign, and then go ahead and experience what that redesign might feel like, as if you were actually there. And it's really a new way to experience design in this third dimension. It's like a 3D version of the 2D section drawing in a way. So here we're actually able to do it for the entire city, and of course, it supports this rapid iteration on the desktop. And now I guess it's time, we're not finished here. We have a design, but what we really want to do is be able to share it with people who are not necessarily familiar with CityEngine. We have web environments and so forth, but what we really want to show here is actually leaps forward in hardware, actually. So we're actually able to take this design and export it as almost as many 3D formats as you can import, and we took it into a game engine here. So we can actually hand it over to you.
Okay.
So, 6. There you go. So go ahead and put the Oculus Rift on there. So what he's actually doing is we're actually virtually placing Eric in the 3D environment that we were designing earlier. And I'm not going to give him the controls. I'm going to let him be a...
Act of faith.
Yeah, right. But, you can actually start to experience... You can experience what it might feel like to actually be a bike, right, on that street, and actually know how that design impacts, your feeling of security. So... So, Eric, how safe do you feel? Would you rather
not
have the
very
roses?
safe at the moment. I have a tendency to break myself. It's a little alarming. So,
great. So there's a lot more to show with these rules. I just have to, say go try it out for yourself. The example is public. Complete streets.
yeah, complete streets.
Mm-hmm.
So I think that's what we have to show you today. We showed doing the initial design in the web, carrying it into the newest cutting-edge desktop technology, procedurally enabling it, doing powerful analytics to inform the design, taking that down and actually doing detailed streetscape design through a procedural method. I will say that complete streets rule is out now, so you can actually go and download the example and start playing with it. It's a pretty powerful and amazing example. So thank you very much.